So you may recognize this picture I had as a background. Who recognizes this? Yeah, you like from some gallery in Madrid or from classical programmer paintings. So I think the title is the Scala tooling ecosystem. In the middle here we have build tools. I'll get around to that. So the purpose of this talk is it's all about tooling. And yeah, I want to talk about some various tools and various ecosystems inside and outside the Scala ecosystem that have the potential to improve your development experience. I'll give some examples like how other languages do it better and where this could lead in Scala land. The talk is structured as a kind of Hegelian dialectic with thesis, antithesis, synthesis, and as you see, illustrated by Hieronymus Bosch and with lyrics by Daft Punk. So the lyrics, fork it, make it, do it, makes us harder, better, faster, stronger. Right. So forking, I'm using this term liberally as something like creating new tools or maybe forking existing tools that make the whole process, they might make the whole process harder to learn, but they could enable better and faster ways of doing things and overall make the ecosystem stronger. So I'm going to assume some basic familiarity with most common tools, but give an overview of various other things. So let's zoom in quickly on stuff that tools help us with. This is a very much incomplete list. We have learning, experimenting, editing code, exploring, understanding, debugging, building, dependency management, publishing, versioning. I'll give examples of these things shortly. So let's start with the first section, learning and experimenting. So I think this is actually a very important and maybe underrated part of the whole programming experiences. Like, even if you're not a beginner at all, you will constantly come in contact with new libraries, new frameworks, code written by someone else on your team that you've never seen before, but now you have to fix it. So we have to learn and figure out how this stuff works. And just reading code helps, but is not that great. We want fast feedback loops to improve our productivity. So the classical tool for fast feedback loops is the REPL, the read, eval, print loop. Scala comes with one. IntelliJ comes with one. Improved one is the Ammonite REPL by Hao-Yi Lee, which comes with various features such as history search, syntax highlighting, block input, undo, redo, importing artifacts straight from Ivy or Maven, and many others that I don't even know of. A different approach is the worksheet, where you keep a persistent file, you could say, around that you edit, you change it a bit, and you run it. Here I'm using the SCASD worksheet to import the GigaHorse library. You see it runs with SPT in the background. I'm just trying out an example from the GigaHorse HTTP library website and editing a bit. And I'm just going to use it to download the worksheet I'm working on right at this moment. Let's see, run it quickly. Yeah, and you see some HTML, and it starts over. So this, unlike the REPL, which has just line-by-line input, and the REPL keeps a persistent state, the worksheet just reevaluates everything at once. But this is practical for sharing code examples, for instance. We also have a worksheet in the Scala plugin, by the way. So another approach, my favorite actually, is the notebook, which is a bit of a cross between Worksheet and REPL. So you keep a persistent state around, but you also have a multi-line editor where you can start back and change things after evaluating them. Here I'm showing the Jupyter Scala notebook, which is actually based on a Python notebook. And I'm just using it to experiment a bit, create a histogram. A common feature of notebooks is that they have some graphical output that allows you to get quick graphical feedback. That makes it more popular with data scientists. I think one reason we don't use this enough is that it's badly integrated with full projects. So I can use it to, like a REPL, but not within my project to try out stuff in my project. We might be improving this in the future by morphing our worksheet in the IntelliJ Scala plugin to a more notebook-style interface. The worksheet actually came from Mathematica originally. The first version that came out in like 1988 premiered this design, and I think they still have one of the best, not worksheet, notebook versions. They use it for documentation as well as for the regular interface. So here I'm just looking at the nest function, messing around with it, changing some parameters. I found a cute example here, changing an X to an U in a Sierpinski triangle. Got inspired to just here import a picture of Václav Sierpinski, scale it down a bit, and to 20 pixels, and put it in here, and you got a Sierpinski triangle. You're welcome. So, in my opinion, this is like the gold standard for documentation. If we have a really interactive documentation that's not only type check but actually executable, changeable on the fly. It would be great if we could get somewhere in this direction in Scala. So editing and understanding. So editing is not just typing code unless you already have a really good idea of what you are going to type. Most of us don't. So you often need to understand the code in front of you as well. Here's another example from Mathematica. I'm using it to input just some random math formula with a square root, a sum. And Mathematica pretty prints it as a mathematical formula because that's what it does. You see, I can just press a button and it changes the output. Or I can use a function like here, input form, to change it back to a form that you can input easily, or full form, which changes it to a kind of Lisp expression style syntax, or even the tree form, which gives you a full tree of the same syntax. So multiple ways of viewing your syntax. I think that's something that we're missing in in most programming languages, where we explicitly write it one way to help people understand it, but mostly to help ourselves understand it, and others think a different way about how the semantically same code is structured, so they might have more trouble with that. One thing I came across is down from the ivory tower back to bare metals, the interactive disassembler. So if you disassemble some machine code, and then you'll just have long lists of assembly symbols. And that's not so intuitive to understand how the structure. So this renders a nice graph view where jumps are rendered as edges between different chunks of code. For Scala, which is a more structured language, this might be not quite as applicable, but an approach I found was this code Bubbles IDE. It went around a few years ago. It's still being developed. It's based on Eclipse. And what you see here, you open not a file, but like a method, for instance, in a bubble. And you can open a definition, and it opens in another bubble side by side. So you can see the usage and the use site right in front of you next to each other without having to mess with editor windows and splitting them and moving files around. I think this is a great approach in making like files a second-class citizen of code organization, because I think files are a pretty crude mechanism for this. And yeah, it allows you a more semantic way of exploring your code, structuring your work environment. This thing is an IDE. Unfortunately, it's not very powerful. It doesn't even import Maven or whatever. It would be great if someone worked on IntelliJ integration of this concept, I think. Okay. Compiling. Are compilers even a tool? Yeah, you might argue not, but they are kind of the interface between you and working software. So we've all worked with a regular Scala compiler. There is, for instance, there is an actual fork here, the TypeLevel Scala compiler, which aims to bring new features to the Scala language as a sort of a testing bed, especially for projects in the TypeLevel ecosystem. So you want to add a new compiler feature, and if it has a reasonable chance to be added to regular Scala, then you will probably have it merged more quickly in TypeLevel Scala and can try it out and base your work on that. Different approach, the reasonable Scala compiler created by Eugene Burmako at Twitter. He's not pictured here. Oh, there you are. There he is in real life. Cool. So, would you like to give a sentence about reasonable Scala compiler? No, yeah, but that's the basic idea. A more experimental re-implementation of the Scala compiler to explore performance issues in Scala, find out what kind of features have a bigger performance impact, and either eventually maybe this will turn into a real Scala compiler. Maybe? Yeah. Okay.
It's an experiment, right?
It's an experiment, yeah. Or maybe the learnings will flow into the regular Scala compiler. Okay. Not a compiler, but a compile server is Bloop, developed at the Scala Center by Jorge and Mata, right over here. It's a server that runs in the background and is meant to speed up your compiling by keeping a hot instance of the Zinc incremental compiler running. It has integrations with various build tools, so you may be already able to profit of better compile times in Gradle, for instance, which uses a very old Zinc version at this point. And it also integrates with IntelliJ in the latest nightly version. I'll talk a bit more about that later. So compiling is the integral part of building, but building involves much more, such as managing dependencies, putting stuff together into a releasable artifact, publishing, whatever. And I did a little research, and it turns out developers in general don't seem to be very happy with their build tools, as evidenced by the fact that there's a build tool ending in ake for just about every letter of the alphabet. Yeah. And I think none of these are actually Scala-focused build tools. But we've got plenty of our own aches, head aches with Scala Tools. We have the classical JVM ones, such as Ant, Maven, Gradle, that will also compile Scala. But we also have the Scala focus tools such as SBT, CBT, Mill, Fury. Yeah?
It's got one user.
Fury has one user. Yeah, Fury by John right over here. Maybe soon it will have more users.
2 months.
In 2 months it will have more users. All right. And like the mono-repo focus tools that are sort of all inspired by Basil. And there's also Pants and Buck by Facebook. Get it? Yeah. So one quick look at Basil. One of the main ideas is that you have reproducible and fast builds that are correct. So Basil aims to achieve this by defining build tasks fully in terms of their inputs, so you don't depend on any magic environment variables. Everything has to be specified as an input to a build task. And this enables you to cache the outputs efficiently and keep them around, even share these caches between different machines, for instance. Quick look at the Scala focus tools. So if you remember very old versions of SBT, they tried to define a build only in terms of Scala, as a Scala library kind of. SBTs have moved away from that, and some people weren't happy with that, so they created build tools that aim to simplify the complication, aim to simplify the configuration again by using plain old Scala. So CBT and Mill are similar in that regard, also similar in that they keep an instance of themselves around based on Nailgun, which enables quicker command feedback as opposed to starting a new JVM every time. They differ slightly, for instance, in the way the configuration exactly is implemented. In CBT, everything is really plain Scala build graph, plain Scala methods that you call. So the task graph is basically just the method call graph. Mill uses a little more magic, so that allows you, like in SBT, to have an inspectable task graph. And it takes some inspiration from Basil as well by having tasks where all the inputs are fully defined so that they can automatically be cached, whereas CBT leaves caching to each implementation of a task. Okay, so as open source developer, occasionally you want to make a library available to everyone in the world. In Scala and JVM land, this has traditionally been tedious. There have been text adventures written about it. So I looked at other places, such as Rust, the cargo. The Rust package manager is cargo. So I'm just going to create an API key here on crates.io. And I'm trying to, I'm using cargo to create a new library, empty library. I'll have a quick look at it in VS Code. What does it look like? It's just a simple configuration file. Apparently they don't believe in Turing complete configuration. So I'm just going to add this to Git, do some commit, and try to publish it. Do some updating registry stuff, sending, and I get an error. I still didn't fully configure it for publishing, so I'll just add a description and license. The WTFPL is appropriate, I guess. And going to try another publish. Well, commit first, right? And publish. Does it work now? Yeah, looks like it's going through. I'll check the crates.io site, and it popped up right there. Nice. So this took about 2 minutes of real time. I don't think I could create a ticket on Sonatype in that time. Contrasting that with Elm. Elm has a similar publish experience. It's more based on GitHub, so your project needs to be on GitHub, unlike with Rust. I already published a project here, and what I'm going to do is I'm going to update it. I'll make it better by adding a better function. I'm going to try to just look at what changes there are. So Elm has this neat little tool, an API diffing. So it tells you if you add a method, if you add a function, then this will be a minor change. And yeah, here.
Oh, this is nice.
Yeah, it's pretty nice. And so you can automatically bump it up to the new minor version. And yeah, it changes the configuration file for you. And let's see if we can, we can commit, of course. We're going to try to publish this. What's missing? I need to tag it, okay. Add the tag, but it's pretty straightforward. Try another publish. Okay, success. And we have a new version online, version 2.10. And likewise, I thought, okay, I don't want to make this better, really. I'll make it unbetter. So I'm just going to remove this method. Going to check the API diff. And yeah, this is a major change because I removed this function, incompatible. So I'm just going through the same process again, bump. Yeah, automatically bump the version, publish, right? Add the git tag, push it. So I think this would be really cool in Scala, but our API compatibility story is probably a lot more complicated. But we could probably cover a lot of ground just by looking at type signatures. So there you go. Version 3.0 is like before. Okay, next step, dependency management. In SBT, we're semi-stuck with Ivy, which tends to be kind of slow in resolving other dependencies. There's actually a drop-in replacement, Corsair, you probably heard about it. It's a little bit faster. So if you add it as a SBT plugin, you can speed up your updates, especially in IntelliJ, which needs to do a re-resolve of things quite a bit. It unfortunately doesn't work for every case, but I think for most cases it works. And I think there are efforts going on to integrate it more closely with SBT. The newer build tools like Mill and CBT use it by default.
Is that the Corsair plugin you were just showing?
Yeah, this is Corsair.
What is the name of that plugin?
Excuse me?
What is the name of that plugin?
Corsair. SBT Corsair. A bit of a different approach. Yeah, we've talked a lot about source dependencies. Nix is another way of packaging stuff. So it's more of, yeah, it's actually a package manager and not such a dependency manager. But it follows similar functional ideas. So, like Basil and whatever, you fully specify your inputs. You make an isolated environment where all your environment variables are defined externally, so you don't depend on magic things outside, and build everything from source. And again, you can package, you can cache these output packages. So it's not really a build tool. It's more general, but also more granular because you don't have like individual targets, individual modules. It's just one source software artifact is one Nix package. It's possible to transform SBT projects to Nix with a plugin called SBTix. I haven't tried it yet, but seems cool. So yeah, source dependencies, they may have problems, but they seem to make a lot of things easier in terms of getting software out there for everyone. And so wouldn't it be great if we could just resolve them from GitHub? There is a service that helps you with this, Jetpack. You just add a Jetpack Resolver and depend on GitHub repo in SBT format, for instance. Just give it a commit hash or a tag, and Jetpack will actually build it for you, build the artifact for you. I'm not quite clear where the limitations of this are, but for regular projects, it seems to work fine. So that's one way of getting development builds out quickly without having to deal with Sonatype or whatever. Okay, so I gave an overview of all kinds of things outside of the Scala ecosystem and inside, and what stuff we could try out. But what about the tools we already have that we're already putting a lot of work into? So here comes the antithesis. More than ever, hour after, our work is never over. What does this mean? Yeah, so we put a lot of work into tools existing, such as SBT and the Scala Compiler and IntelliJ and so on. And we've become used to these tools. So, and learning new paradigms, learning new tools, that's quite a bit of cognitive overhead. So why don't we work on the existing tools to make them better incrementally? And of course, there is progress in that direction as well. The Scala Compiler is being continually developed by Lightbend mostly, and many contributors. And they're trying to make stuff easier by simplifying collections, by removing can build from the user-facing API. Improving compiler performance, of course, continually. And just more general user-friendliness, whatever that means. SBT as well, it's been around a while, since 2009. It's also being maintained by Lightbend mostly. Dale over here, Eugene isn't here, but doesn't matter. So as you may know, it's used for the majority of Scala builds. So any improvement we make on it will benefit many people directly and quickly. There are also lots of plugins that depend on it that enable very specific workflows, tasks. So on the near-term roadmap, we have things like cross-JDK testing, easing the contributions by labeling issues, by taking part in Scala sprees like we had on Tuesday before the conference started, organizing tests and code better. And of course, I have to mention this IntelliJ Scala plugin thing. It's been around even longer, since 2006 are the first commits I saw. I've been only working on it for about 2 years. Currently there's 9 people on the team, and we have quite a lot of things on the roadmap, closer and farther term, such as Scala format support, better semantic highlighting, fixing the error highlighting one by one, and maybe in future more thoroughly cool thing I'm calling implicit radar, making the first step easier with a one-click distribution, and other things. So a short demo of this one-click installer. So if you remember how you installed IntelliJ, who's actually using IntelliJ? Yeah, that's most of you. So yeah, if you remember installing it, it might have been a 100-click tedious process. It's a little easier. I just downloaded this bundle. One click, open, load, and we have hello world. and just run it. It comes with JDK and SBT and everything you need to just get started quickly with Scala and edit.
How big is it?
Like 300-400 megabytes. That's less than half of the usual community distribution, because it takes away a lot of the things you don't need for Scala, like Kotlin or something. Yeah. So, yeah, I'm calling this the implicit radar. Pavel back there has been working on it. So, yeah, we want to see what's up with implicits. So just going to press a button and see what value is actually being passed to as an implicit parameter, or when a value, implicit import is missing, or when you're passing an implicit explicitly as a parameter. And here also it shows you implicit conversions. And the same thing for a standard library, shows you what implicits it's taking from the standard library to make all these collection functions work. So yeah, work is happening, but I think the dichotomy between we should fork things and create new things, new better way of doing things, and no, we should work on the stuff we have and make it better. It's a bit of a false dichotomy. We can integrate or synthesize. So yeah, this is the final part of the dialectic, the synthesis. Fork it harder, make it better, do it faster, makes us stronger. More than ever, hour after, our work is never over. I'm not done yet. Still got a few minutes, right? So if we can agree on certain protocols and formats, we can better integrate the old with the new. We can easily integrate IntelliJ with new build tools, for instance. So there has been work happening in various directions, improving both old tools such as Jorge, for instance, from the Scala Center, working with SBT to improve the experience. Also, I've been working with Jorge a lot recently on a little thing we called build server protocol. More on that in a second. And likewise, I've also been working with SBT developers to make the SBT integration smoother in IntelliJ as it exists. First sidestep, there's not only IntelliJ, so you may have heard of metals and the language server protocol. Who knows about the language server protocol? Oh yeah, that's plenty, but not everyone. So it's a kind of a tooling protocol developed by Microsoft for Visual Studio Code initially, but it's now supported by many more editors and many language servers, so tools that compile stuff for you and give error messages, for instance, and communicate them to an editor. So this solves the problem of every single editor needing support for every single language, which in practice doesn't often happen. So Metals is currently a more prototype implementation of such a language server for Scala. Likewise, dotty or Scala 3 in the future comes already built in with such a language server. So currently the standard editor for dotty is VS Code, but we're looking at how to support dotty as well, hopefully more fluently by integrating with a Scala Compile server in IntelliJ. But at the moment, you already get basic IDE features for dotty via LSP in VS Code. So the build server protocol I mentioned. So you've heard of the language server protocol, which communicates between language server and editor. The build server protocol sort of extends this notion to build servers So basically build tools such as SBT. Currently, it's only supported by Bloop on the server side and IntelliJ on the client side. So in the most recent nightly, you can try this out. I'll give you a quick demo how it looks. So I'm going to open my IntelliJ here and going to import project. So it's very similar to how it works with SBT. There's my IntelliJ's. Where is it here? So only you have an additional option called BSP. And just do the import here. Okay, yes. I'm importing the IntelliJ Scala plugin project itself, and the window jumped over to my other screen. Oops. And you see it fairly quickly imported this. It's a bit of a cheat because I already exported the project model to Bloop beforehand. But this already enables you to work with projects together with Bloop, compile your projects with Bloop. It also works for projects that are not SBT based, but only Bloop, which, for instance, Kaleidoscope, we just ported it to M11. Kaleidoscope doesn't use SBT or any build tool besides Bloop. And you can actually edit it in IntelliJ with all the regular niceties you have. You see, I can task runner, oops, open files, I don't know, navigate somewhere. Everything seems to basically work. I can do a compile and I will get a nice output right here. It's still taking a while because it's a fresh compile. But it will give you a long list of all the warnings and errors in a nice tree right here. Okay, continuing the talk. So those are just some examples of IntelliJ integrations. We have plenty more, as you may know. We just recently added support for Ammonite scripting. In the ultimate version, you'll find support for Play, Scala.js, Akka, maybe soon Spark, and the experimental build server protocol. On my Twitter, you'll find a link to a document describing how to enable it because it's hidden by default because it's still experimental and has too many rough edges. So concluding, this is the point where I am supposed to inspire you to get involved in all this synthesis, in working together to improve the state of our tooling. But maybe you have a job and a life and aren't getting paid for tooling. But perhaps you should consider how much time you spend working around tooling, and if your team or company can support this somehow, making the tooling overall more fluently. And on a company level, you can, for instance, support this by becoming a sponsor for the Scala Center, which works on things that benefit the whole Scala community. Or you can buy IntelliJ licenses and keep me paid. So, yeah, get in touch. If you didn't know, the IntelliJ Scala plugin is open source, Apache licensed, all of the community version. And if you think you need to fix something, just get in touch and we'll try to figure it out how to do that and how to help you fix something on your own if we don't get around to it. So here, this is the Q&A pool. You can jump right in. And any comments? Yeah?
Tweet out your slides after this.
Yeah, I'll tweet out my slides and they'll also be published by Scala Days, by Lightbend, I think. Yeah, sure. Yeah, so the question was, is there a tool for internally caching dependencies in a company? Because that's one of the major things that take a long time. Yeah, you can install a local artifactory or Nexus that will cache all remote dependencies. That helps a lot if you don't have a good internet connection to wherever they're hosted. And you can also publish your own internal dependencies there as well. Some developers are more productive by using Vim. That's perfectly possible. If you miss Vim key bindings, there's a plugin for that. But if you miss Vim as such, sure, then use Vim. Not every tool is for everyone. Any other comment you had? Okay. Yeah. Anyone else? We're done? Okay, then thank you. I'll be around.